We can also create the standing wave in the lot or even in the two-dimensional plane. For example, in fact, you have to do this in the laboratory. That is, if you have a metal rod like this and you clamp it in some certain point and then you throw the rod, you can make the longitudinal oscillation. That is, the rod will oscillate in this direction, and you can make with the appropriate frequency. You can also make the standing wave in the rod. And again, when you make the standing wave, it means that you disturb the rod with the natural frequency and you create the resonance in the rod. In this situation, we can see that if we clamp the rod at this position, it means that the rod cannot move at this position. So it will be the node for the displacement wave here at the position that you clamp. And at the open end, the rod can move freely. So we must have that this is the antinode for the wave, for the standing wave in the rod. So in this situation, if you clamp the rod at the middle, and we will have the situation here that we have the antinode at this end, the antinode at this end, and the node at the middle. So from this figure, you can see that if the length of the rod is L, we must have the lambda is L is half of the lambda, or the lambda is equal to 2L. So the fundamental frequency in this situation is equal to the V over 2L. This is equivalent to the standing wave in the air column with two open ends. Okay. But if you clamp the rod in a different position, like here, you can see that at this position it must be the node, and at both free ends must be the antinode. So if you clamp here, you must have the antinode and then node, and antinode again and then node, and at the end is the antinode. So in this figure, we clamp the rod at the distance L over 4 from the left end. So this is L over 4 and this is 3L over 4. So in this situation, you can see that we have the standing wave with the wavelength equal to L, because this is complete one cycle of the wave. So we have lambda is equal to L, or the frequency is equal to the V over L, which is 2 times of the first situation. We can also create the transverse wave in the rod. There are many musical instruments that you may knock the rod and you create the vibration in the transverse direction, and for the proper frequency that you disturb the rod, you can create the standing wave, and that again we have to say that you create the resonance in the rod. You can also create the standing wave in 2 dimensions. This can happen in the drum because we disturb the surface of the drum, and with a suitable disturbance, we can have this standing wave. Okay, I have shown you in the clip that demonstrate the standing wave, and we can observe the node and the antinode by looking at like if we put the salt or some kind of small particle on the surface of the vibrating surface, and then we can see the pattern of the standing wave on that surface.